Hey guys, what's up? This is a video on the quadratic almost ideal demand system. Let's go. The quadratic almost ideal demand system is an extension of the AIDS model, which was first introduced by James Banks, Richard Blundell, and Arthur Lubell in their 1997 paper, Quadratic Angle Curves and Consumer Demand. They noticed that there exists a polynomial relationship between supernumerary income and some goods. The reason why this is important is because budget share equations given by our AIDS system only allow for straight angle curves. Mathematically, recall that our budget shares in our AIDS model is defined as the following, where our budget share for good I is equal to alpha I plus the summation of all prices j times gamma ij plus beta I times log m over p, which is our index of supernumerary income. Estimating our angle curves from our supernumerary income, we have beta I, which is a straight line slope coefficient. What the authors suggest is by inclusion of a term which is quadratic in supernumerary income, this further fleshes out our income expansion paths for our system of consumer demand. This, however, requires a redefined version of our demand system that we are estimating. To obtain the budget shares that we want, instead of an expenditure equation, the authors propose the following utility function, where log V is our log utility index, log M is our log expenditure, log AP, that's our translog price index, BP, right, that's just a price aggregator, right, which is the product of all prices I raised to the power of beta I, right? In the regular AIDS model, this is defined as beta naught times the product of pi raised to the power of beta I, where the inclusion of beta naught really is unimportant because it's an irreducible term or unestimatable term. Lambda p, right? That's our stone price index, right? It's estimated in this context without a constant. And the reason why we're going to include this is because if we want a quadratic relationship, we have to incorporate a second price index, but without over identification. So we're just incorporating B again, except we're going and we're logging it so it's not perfectly identified. The authors say that we can obtain our desired budget shares by using Roy's identity, right? It should be noted that this term, right in the middle of our utility function, log M minus log AP all over BP, that is our indirect utility function for our regular almost ideal demand system. So calculating the budget shares using the method on the previous slide, we obtained the following, where we have just the regular budget shares from our almost ideal demand system plus a quadratic term, right, where our coefficient is a little bit more interesting if you go and you estimate this using the linear approximate sort of method, because you could go and estimate each one of these equations separately. The calculation of this is largely not really so relevant. They propose actually a different method, which of iterated least squares for going and estimating this model, but I'm not going to talk about that in this video. So moving along, the properties of this model are budget balancedness, Slutsky symmetry, and homogeneity. And our fifth property is the Slutsky matrix must be negative semi-definite, which means it must be concave in prices. P1 to 4 are imposed by construction. However, we have to go and test that our Slutsky matrix is concave in prices. This is necessary for proper specification of the budget shares that we are going and estimating. So on this last slide, I just want to go and show you the uncompensated price elasticities, the income elasticities, and the compensated price elasticities in terms of how they're calculated on this slide. You can just go through it over here. I'm going to probably talk about actually showing negative semi-definite of the Slutsky matrix in another video. I know I said that a while back, but it's going to happen, guys. I'll see you sometime later. Take care.